Here's one for you to try. Given that the heights of women in Malaysia are normally distributed with a mean of 154.7 centimeters, so they're shorter than the Canadian women, and a standard deviation of 6.46 centimeters, calculate the z-score of a Malaysian woman who is 159.1 centimeters tall. I wrote down the formula for the z-score formula, and I used mu and sigma because, again, they're talking about the heights of women in Malaysia are normally distributed with this mean and standard deviation. So for the population of Malaysian women, this is the information we have, so mu and sigma are appropriate. But remember, it's still going to be whatever your data point is minus the mean over the standard deviation. And we have a data point of 159.1 minus 154.7, which is our mean, divided by 6.46, the standard deviation. So I'll show it to you on the calculator and kind of talk you through in case you're still struggling on this part. 159.1 minus 154.7 equals, and I get 4.4, so I'm going to definitely leave it sit on my calculator just because it saves me time, and then I can write it down. If you prefer, you can write it down, but really I want to see this line, and your final z line. I don't mind if you don't write that intermediate step. So 4.4 divided by 6.46 equals, and I get 0.6811, so my z-score is going to be 0.68 because I need to round to 2 decimal places. So I have a z of 0.68. Now, you weren't asked, but I will be asking shortly, so I'm going to draw a distribution so we can be getting used to that. And remember, you have written in those markers using the mean, so we could do that 154.7, and that's going to be an x value. I know I'm going up, so 154.7 plus 6.46, and I get 161.16. And plus 6.46 again, 167.62, and 174.08. $154.7. So I've written in all of the x values based on this mean, and then adding or subtracting off this standard deviation, just like what we did before. And then remember, we're concerned about a woman whose height is 159.1, so I can see by my data values that she's somewhere in between here. And when I find the z-score, it's 0.68, and that tells me it's not quite to 1, but it's over half, almost at 3/4. So if I put a line about here, that would be about 0.68 standard deviations above. So 0.68, and then 1, 2, 3. Those would be z-scores, -1, -2, -3 also. So in red, I listed my z-scores. In blue, I listed my x values. And you can put both of them on a distribution as long as you have a mean and standard deviation. It's a good idea to kind of get you used to both. We use the z-score formula to convert from an x value to a z-score.